We will talk in this last, let's say, technical presentation, how to automate Sigmafine to support data conditioning for business processes. So we will introduce the business context. In reality, we are talking about different needs of business since the beginning, from the keynote led by Massimo to E&I presentation and so on. So I think you already understood why there is a need to improve the automation. We will see briefly some use cases. Again, some of these have been already introduced in our presentations in more detail this morning. And then we will see how to achieve a automated or partially automated validation and reconciliation. So typically you need to manage large volume of information. You want to get out relevant information from these data sets. And you want to do the right decision at the right time based on such information. So how to address this large volume of information? AF is one of the answers. So standardize the representation of your assets, use templates, and Sigmafine natively comes with templates. Select with adequate data granularity, so in terms of time and space, but specifically here we are talking about time, and do appropriate analysis on such data. Now you have available really nice tools to go in very detail and get out prediction, deep analysis. There are different business intelligence tools, analytics, there are statistical languages like R and so on you can use. But the other pillar is integration. So if in an automated environment, you have to make sure that all the data sources are integrated when collected, and even this should be done automatically. The PI system is already integrating lot of data sources. You may have some other data sources to aggregate through interfaces. You need to make sure that all these components are talking at the proper time. And finally, data analysis, and here I'm speaking more specifically about Sigmafine. You may also think about increasing the depth of analysis. So maybe you started with mass balance, and on top of that, you may think of adding additional analysis like composition tracking, quality tracking as done by E&I, or component balance and so on. On that, you will provide that you should put in place an automatic data validation, and based on reconciled information, you should then improve, let's say, from the past data, your future prediction. Also, users are important in this process of automation. So the idea is that we don't want to get rid of people. Accountants are still important. We just want to decrease the effort they do and make their time more valuable. So make data accessible, easy to use. Of course, it's important that users are trained in the use of these new tools, and in the end achieve a better user experience. What are the benefits on a business side? We talk a lot about yield this morning, also energy management, supply chain. So I'm recalling now all the presentation we have seen, like needs for supply chain, and in the end get a better evaluation of the relevant KPIs for of your facility. So coming to some real use cases where we already implemented some automation of Sigmafine. Okay, two of them are have been already touched a bit. So one was touched in more detail by Elena's presentation this morning about this furnace. So at the bottom of the energy calculation, there was an automatic engine allowing to do hourly mass and energy balance reconciliation of this equipment. So here Sigmafine, I just remember you, is providing a lot of information, many of them even not measured but inferred through the model, like, and in this case also with the aim of a thermodynamic extension, like to provide the amount of vaporized crude, the calculation of the duty, of the efficiency, and such information were then used by the operators to improve the operation, especially in this case on the topping column. Another example we saw a bit this morning, this distillation column that purifies ethylbenzene from styrene is a very energy intensive equipment with a very big reboiler. We see a bit below here a part of a Sigmafine model that has been implemented. Again, here the aim was to come closer to the operations so that the operator in near real time, in this case the run was around every 10 minutes, had an update of what was the real steam consumption against the purity of the products. And so work closer to the limits, lowering the steam consumption of the very boiler. Third case, in upstream, in this case, the aim was to validate, again here, around 10-15 minutes, the status of a three-phase separator, the three-phase meter against the separation in between gas, oil, and water. It's using a mass and component balance. The result for 3 different wells is shown in this last, in the picture on the right. So for wells A, B, C, the first box plot is the measured data. It's the measured gas to oil ratio together with their accuracy. And the second one is the reconciled. And we can see that with the accuracy of the reconciled, we should remember the Sigmafine also give you how accurate is the reconciled data, not only the measured. And we see a big discrepancy on the first one, so it means probably that meter had to be recalibrated, while the other two are quite in accordance. Now, we should ask ourselves how to do that. So, if we want to use Sigmafine automated, unattended, so there is nobody taking care that all the data are good, are fitting well, that your model can be solvable everywhere. We need a model which needs to be more robust and face and have strategies to handle uncertainties. Uncertainties like bad data or missing data, out of range data, spikes. I just try to find some of the most common process, some of the most common data issues that we can face. But there are ways to deal with such problems. We will see some simple example. In the literature, there are even more sophisticated methods. We selected the ones that are quite easy to implement so that everybody here in this room could implement on top of their AF. Some of them can be done directly, can be done in Sigmafine, some others directly on the raw data in with Pi, for example, through Pi Analytics. Overall, the overall idea is that during the data collection, you don't send directly the raw data as input to the Sigmafine analysis, but there is a validation stack in the middle where the Sigmafine checks the raw data if it is fine or not, and if it's not fine, acts in some way. And you can specify some rule, and thanks to the flexibility of AF, you can decide which rule to apply in case you encounter a data issue. So, for example, about bad or missing data, we should remember there is a threshold associated to each pi point that, during the aggregation, and you can, for example, lower this threshold to make to relax a bit the system and be more tolerant to the number of bad data you can get inside the case. But still, you would like to monitor the number of data you have in the case you're handling with. So to be sure that you have at least a minimum amount of data for the specific case. So we see on one side you are totalizing with a threshold. In the second case, you can count the number of events, and so the number of data that are recorded in the historian. And on the basis of these two values, you can then put inside a validation rule that checks if you have a bad value or if the number is not enough, and you can decide what to do, which value to use in case something fails. For example, you could decide to use the previous reconciled data or a default value or something else. In case of deviation, you can decide to clip the data between a minimum and a maximum, and you can put this into some attributes. So you can put this validation rule automatically in the template so that it's applied everywhere. Or you can do the same but directly on the Pi data. So for example, if you have a valve which normally is thought to be between 0 and 100%, but for some reason you are handling a different range. In some cases it happens that you want to have a valve, when the valve is fully closed, you don't associate a 0% but a negative value. So to assess that the value is really closed, because you may have a limit switch. Okay, but if you aggregate data on the basis of a, I don't know, -5%, you're making a wrong thing, because still in Sigmafine you expect 0 and not -5. So it makes sense instead to clip the data between 0 and 100. This other slide instead tries to deal with spikes. Okay, in Sigmafine we are quite lucky because data aggregation natively handles spikes. Here we have an example of 80,000 data points of a flow rate that is moving from 0 towards a set point. We can see that there is some dynamic, but also data spikes due to some noise. Could be process noise or the instrument noise itself. We should remember that when we totalize the data in Sigmafine, so we do, in reality, the integral of a variable along the case duration. And if we do, for example, on a daily basis, what happens is this trend. So natively, so the spikes, it's true that are very large value compared to the average, but they last for a very short time. So when you do the integral, their contribution is quite small. The other thing you can do to reduce spikes is to do some filtering directly in the Pi system. Here we just put the example, a very, very basic example of filtering with a low-pass filter, where you can have a parameter that typically depends on the process, where you can decide which weight to give to the new value respect to the previous filter value. So you can wait a bit, and this filter decrease the spikes in the data. With statistical detection, we mean some methods instead to address problems like data freeze, or on the opposite, unsteady state conditions. Still, we can calculate standard deviation of the data within a certain time range. If the standard deviation is less than a small acceptable number, okay, probably we are in the case of a data freeze, and so we can raise a flag and eventually decide what to do in case of data freeze. Still keep the value, or supply a different value, or some other strategy, but at least we have a method to detect. So you could apply a PI notification, or record in a dashboard that there is some data issue. For data drifts, again, there are several methodologies. Again, we tried to find one which was simple enough to be very easily implemented within AF. You could compare the average value on a short time frame respect to a longer time frame. Here we are comparing 1 hour respect to 1 day. If this difference is larger than 3 times the standard deviation, still this could be a good indicator of data drift. And so again, we could set a flag and notify that there is some deviation in the process. It might be fine, so it's the real process that is changing. It might be an issue. Okay, then the user is at least enabled to check and know the source. Other ways to improve the Sigmafine model in an unattended way is to improve the redundancy of the model. We have seen also in the presentation before done by Katia and Isabel how important was and the effect of adding a meter to improve the overall redundancy of the model. If you already finished your physical meter, you still can add information based on your process knowledge, so create virtual meters to supply information for unmeasured flows. You could put some numbers just based on an engineering rule of thumb. It's the most basic way. You can use correlations. So, for example, you have a flare line that is not measured because you have the meter just on the overall flares, but not on the single flare lines. But maybe you have a valve and you are recording the opening of the valve, and you know the pressure, also the pressure is recorded before and after the valve. Well, you include the information about the valve inside the AF, and you can estimate the flow rate. So we learned so we are putting process knowledge inside the model, and this will improve greatly the robustness. The same you can do for if you are doing energy balances around heat exchangers. If you model not only one side but both the hot and cold side, again you are adding a redundancy of information because they should match. Or add its losses. If you are in the example of the furnaces, it was not only model the process, but also the radiance losses have been included in the model. And finally, another way to increase redundancy is put inside thermodynamic relationships. So here we are presenting, for example, a case of a knockout drum, so a separator of the vapor and liquid phase, but in the process we only measure the inlet. So this is a non-solvable balance point. We have no redundancy of information, so Sigmafine would mark this as non-solvable. But if we also know the composition of the stream and the temperature and pressure measurements, then through the thermodynamic extension, we can estimate the separation of the two phases, and so the vapor and liquid flows. So now the system becomes solvable. So this is another way to improve the redundancy of a model. How to automatize? Well, we should remember within Sigmafine installation, we have a component which is called Sigmafine Scheduler that can automatically perform the tasks. You can decide which task to automatically perform. There are some customers that are using this just to collect the input during the night, so that the accountant in the morning already has all the inputs collected. It's a first use. In a fully automatic unattended case, well, probably we will run automatically, we will publish the data back to Pi, maybe we publish also to a SQL Server database, which automatically maybe feeds a BI dashboard, like in the, again, I come back to the example of a furnace. This is what it's doing. You can also decide to automatically rerun some of the old cases just to be sure that if there were some issues, these previous cases are for sure run. And you can even run multiple instances of this scheduler. So if you have multiple models, you can handle not only one model at a time, but many of them. And this is the configuration window of the scheduler. Then if you have questions on the details of all this window, you can ask after at the pods. I think there are people that can tell you all the details. So in the end, what we want to achieve, we want to achieve the fact that users are focusing on the results. They are not taking care of how I get the data, how do I process the data. I want to focus on my Pi Vision screens or on my dashboard screens, where I have already all the KPIs based on validated and reconciled data. And so what's working behind is working automatically and unattended. For sure, one of the issues that you may encounter when configuring a system like this, especially if you have retrieving data not only from the historian but from many different systems, is that also all the interfaces are working and scheduled in a correct way such that the workflow is working in all the cases. So to end this presentation, so the main achievement you may have is an automatic meter validation and conditioning. Bill of material verification, this is something asked. For example, we have some customer regarding FPSO, where they get oil and sell oil to third parties, asset monitoring and energy management. This is another hot topic. We have talked extensively today. And that's it. So.